Hello and welcome to voxeljet. Today we are introducing the VX1000 HSS, one of the largest ink-based powder bed fusion systems for polymers on the market, and probably the most productive, advanced and flexible 3D printing solution. When it comes to 3D printing of polymers, you are probably already familiar with 3D printing technologies such as laser sintering or multi-jet fusion. In the following, we will introduce you to the advantages of the voxeljet high-speed sintering process, HSS for short. And for this, we have invited Christoph Scheck, our R&D engineer and HSS expert, to walk us through the machine. Welcome, Christoph.
Thank you.
So, HSS is a 3D printing technology based on inkjet and powder bed fusion, whereby the layers are fused using infrared technology and built up three-dimensionally in the job box. But what is so revolutionary about HSS? What makes the VX1000 HSS so efficient and economical, especially when producing serial parts, but also individual larger components?
It's a really good question. Productivity, profitability and quality are no contradiction with the VX1000 HSS. The VX1000 HSS manages to produce the highest quantities with maximum quality across the entire build space in the shortest possible time. This is unique in this form, considering that the VX1000 HSS, which is 1000, 540 and 200 mm for PA12, is one of the machines with the largest build volumes in polymer 3D printing. The key to this is a perfect balance between printhead size, temperature management and the build volume in the job box.
So, in short, what makes HSS, and in particular the VX1000 HSS, so productive and suitable for serial production?
Well, first of all, at 1000 by 540 by 200 mm for PA12, as already mentioned, the VX1000 HSS offers one of the largest build volumes available in polymer 3D printing. With this enormous job box dimensions, the build space of a job box can always be optimally utilized to reduce the cost per part, no matter whether you use it for large or many small components. In addition, the printer efficiently recycles powder during operation, ensuring an optimal powder quality to keep costs down. In short, it's a combination of high-quality components, large build volume and intelligent temperature control, all designed for high utilization and low maintenance.
So let's take a closer look to the individual components then. So, what is so special about the printer of the VX1000 HSS?
The VX1000 HSS operates with 1 meter wide printhead that covers the entire build area, ensuring consistent layer times and precisely predictable output with consistent quality across the entire build space.
So, is the unusual width of the printhead the only benefit that it offers?
The width of a printhead is the main reason for the constantly high production speed. But of course, there's more to it. The printhead has around 8,000 nozzles and is designed to match perfectly to the inks to be printed. Combined with an intelligent heating strategy, no second liquid, such as a coolant, is required. In addition, the printhead is able to print bidirectionally. Thereby, both passages of the printhead are used with a small offset in between. This made it possible to arrange the piezoelectric printhead modules of the VX1000 HSS in a comb structure.
Can you explain the benefits of this structure?
The arrangement of the bidirectional movable printhead modules in a comb structure enables production with half of the modules, and sustainability reduces the costs of the industrial-grade printhead. As the printhead is designed for a long service life with billions of shots, this construction method not only reduces printhead costs, the design also offers constant layer times, completely independent of the actual box utilization. As a result, this leads to more reliable and predictable production. A clear, unique selling point compared to selective laser sintering, or SLS for short, for example. A process in which the build time clearly depends on capacity utilization.
So, can you briefly explain why the temperature management of the VX1000 HSS increases productivity and speed in series production?
The intelligent and innovative temperature management of the VX1000 HSS ensures extremely homogeneous heat distribution in the job box with a self-regulating system consisting of 6 individually controlled heat sources. As a result, this not only increases the repeatability of 3D printing polymers, but also sustainability, increases the efficiency of the system by avoiding rejects. In the reproducibility accuracy section, I explain the advantages of the temperature management of the VX1000 HSS in more detail.
Let's talk about the large print volume again. What specific advantages does the large job box of the VX1000 HSS offer in production?
The VX1000 has a large build volume of 1000 by 540 by 180 millimeters for PA12 and therefore offers decisive advantages for various applications. It enables the printing of large parts such as impellers or door carriers in one piece, which is often not possible with other technologies. It is also ideal for producing large quantities of smaller parts, enabling genuine series production.
How does the large job box affect production cost? Does it pay off?
Yes, surprisingly quickly. You can reduce the cost per part and remain flexible and profitable at the same time with a job box utilization of more than 10%. For complex, lightweight parts, more than 10% box utilization is quite remarkable. This consistency is crucial for the efficient production of both large and precise parts and makes HSS more productive than laser-based systems.
Thank you. So, sustainable material cycles are becoming increasingly important. What about the recycling rates of polymer powder with the VX1000 HSS?
Thanks for the important keyword. The high-speed sintering process significantly improves recyclability. It minimizes plastic waste and maximizes profitability in production at the same time.
That sounds great. So how does this work in practice then?
The HSS process works with selective and gentle heating, meaning only the printed areas are actually heated. As the unprinted powder remains intact, high recycling rates are possible with high-speed sintering processes. The VX1000 HSS has a closed powder circuit with a recovery unit that ensures optimum powder conditions. The system supports a 75-25 recycling concept for PA12. With this ratio, it is possible to keep the powder flow circular, creating no waste powder, a factor that sustainability reduces costs and improves resource efficiency.
So can we talk about the maintenance effort and maintenance cost of the VX1000 HSS?
Sure. When designing the machine, we focused on minimizing maintenance of key components right from the start. The printer, for example, a key maintenance element, uses industrial piezoelectric modules that are designed for billions of shots and are highly compatible with our applied ink. The system also constantly monitors the ink temperature and pressure in order to extend the service life of the printhead. In combination with a non-contact cleaning system that ensures a long printhead life and avoids frequent replacement of parts, whether we are talking about the printhead itself or the cleaning station. And also, the integrated cooling system helps to maintain stable temperatures and reduces component wear. The infrared lamp, for example, is water-cooled, which stabilizes the energy output and extends its service life to around 1 year. Taken together, this is a comprehensive package of measures to reduce wear and maintenance to a minimum. And also worth mentioning is a low energy consumption of the VX1000 HSS compared to other systems.
HSS is a 3D printing technology based on inkjet and powder bed fusion, in which the layers are fused using infrared technology and built up three-dimensionally in the job box. But what does the HSS process achieve in terms of reproducibility and accuracy, especially in repeatable production of many small parts, or let's say a few big parts that are dimensionally accurate?
Printing large and accurate parts with dimensional accuracy and without deformation, that's it. The printer makes it possible. The VX1000 HSS achieves maximum repeatability and dimensional accuracy in polymer 3D printing, even with large components. This is unique in this form, considering that the VX1000 HSS with its 1000 by 540 by 200 mm for PA12 is one of the machines with the largest build volumes in polymer 3D printing at all. We reach maximum precision thanks to the perfect interplay of advanced temperature management, process monitoring, and data analysis across the entire production process.
So, in a nutshell, what makes HSS, and in particular the VX1000 HSS, so accurate and precise when it comes to polymer 3D printing of large, dimensionally accurate parts?
Well, temperature management plays a crucial role in achieving maximum repeatability in the 3D printing of polymers. This was a particular technical challenge for 3D printing systems such as the VX1000 HSS with a chop box volume of 1000 by 540 by 200 millimeters. An innovative new approach was required to achieve homogeneous and precise heat distribution throughout the build area. An approach that combines advanced technologies in heat input with modern monitoring and control technology in the 3D printing process.
So how should we imagine this in concrete terms?
Precise temperature management over the entire build area is crucial for repeatability when 3D printing polymers. To achieve this, a VX1000 HSS features a self-regulating heating system in which 5 individually controlled heat sources work together to ensure consistent and reproducible temperatures throughout the production process. In addition to independent heating circuits, the system consists of a sealed and cooled sintering unit that emits wavelengths absorbed by the colored powder to ensure targeted heating, as well as an overhead system with 54 heating modules for precise overall temperature control. Even the heated chop box walls help to even out temperature gradients, particularly at the edges and sides. And the box platform enables controlled cooling during and after printing. This intelligent system ensures uniform temperature regulation throughout the entire process, and therefore consistent print quality and high repeat accuracy for load jobs.
So how is the temperature monitored with regards to ensuring homogeneity and repeatability throughout the build process?
The VX1000 HSS has an intelligent temperature monitoring system that ensures homogeneity and repeatability throughout the entire build space. Multiple parameters and sensors track heat output across the build area in real time, and the overhead system dynamically adjusts each heating circuit to ensure consistent conditions for each layer. This self-regulating system allows for precise temperature control, resulting in the homogeneity and repeatability of each print.
So does the VX1000 HSS also come with the capabilities for data evaluation and monitoring to optimize the process if necessary?
The VX1000 HSS offers robust data evaluation tools and optimize future print jobs. All sensor data is stored in an SQL database and can be analyzed via the VAMAS system. This data helps to ensure consistent part quality by evaluating temperature distribution and so on. If there are deviations between jobs, data from components such as parameters, the overhead system, heaters, and cooling systems can be reviewed to optimize the process. In addition to the sensor data, the machine provides video recordings and infrared camera images that allow further insights into the process. Real-time monitoring is also possible.
So the VX1000 also has a very advanced temperature management system. So what are the benefits for the customer?
Customers benefit considerably from the advanced temperature management of the VX1000 HSS, especially when manufacturing large components. Let's take an example from practice. A customer who wanted to produce a large impeller for SLS, for example, had problems with accuracy due to inconsistent layer times, resulting in challenging temperature control, and subsequently deformed parts that didn't fit, of course. In contrast, the temperature management of the VX1000 HSS monitors the entire printing area in real time throughout the entire printing process and ensures a permanently uniform temperature distribution. This helps to avoid common problems such as deformations and misalignment that often occur with other powder bed processes.
Perfect. So can I say or ask the question that the temperature management of the VX1000 HSS makes production of parts much easier then?
Yes, you could say that. While technologies such as SLS have to contend with fluctuating temperatures, especially during long print jobs, the VX1000 HSS printing process has stable thermal conditions throughout. In our opinion, these constant conditions make the VX1000 HSS the first choice for the production of large, precisely and dimensionally accurate components in polymer 3D printing.
HSS is a 3D printing technology based on inkjet and powder bed fusion, in which the layers are fused using infrared technology and built up three-dimensionally in the job box. But what is so revolutionary about the HSS technology? What makes the VX1000 HSS so flexible, especially with regards to producing parts with special requirements on mechanical properties or application-specific adjustments? How can this be realized for individual parts, but also larger or serial production parts?
Well, maximum flexibility means maximum adaptability in production. This is where the VX1000 HSS sets new standards. The special feature of the VX1000 HSS is its extreme adaptability in various parameters. It enables users to iteratively optimize and innovate production orders from a cost and quality perspective. No matter from which perspective you look at, with the VX1000 HSS, the user is able to optimize the production processes in a short time to meet the exact challenges of a job and reproduce them precisely at any time. And this applies to both current and future requirements.
In concrete terms, so in particular, what distinguishes the VX1000 HSS from comparable systems out there in the market? Especially, of course, with regards to the flexibility.
Well, in the high-speed sintering processes, or HSS for short, the production parameters can be adapted extremely flexible in the software. This enables customers to precisely coordinate the interaction of material and machine in production for optimal results in the respective tasks. For example, parameters such as temperature, ink application, printing and recoding speed, coating thickness, and much more can be individually adapted to the job to meet specific mechanical properties and application requirements. And of course, the job settings can be saved and thus reproduced exactly for subsequent jobs.
And what role does the PrintTech technology play in this?
Well, the print head modules in the HSS system allow precise control of part properties by adjusting energy absorption by varying ink deposition. Using grayscale printing and differing techniques, the inkjet modules can vary droplet sizes and spacing to fine-tune the ink input in different areas. With VX1000 HSS, the user can determine the material properties of the end product in an unprecedented range. Very thin wall thickness, allowing, for example, translucency, are possible to print. HSS technology can be used to control the material properties and production in all three dimensions, influencing mechanical properties such as strength, elasticity, or density. In addition, the system can differentiate between skin and core and, for example, adjust the outer shell of the part separately.
Interesting. And is all this possible with the standard VX1000 HSS? What can this feature do in practice?
Well, no, these settings are no standard. Different print modes can be customized to meet customer needs, either by us or by the system operator. These settings allow for a job-specific balance between mechanical strength, elasticity, surface quality, and ease of unpacking. These configurations utilize a varying balance of individual process parameters to meet different requirements. An example may be via temperature adjustments or a higher ink to powder ratio. The fusion of the layers and the mechanical strength can be increased, but at the same time increase powder adhesion and make unpacking more difficult. But it can also be adjusted to facilitate unpacking and reduce powder adhesion, but can reduce the strength of the end product. The variation of the ink droplets, for example, can influence the elasticity of the parts. The print modes of the VX1000 HSS, for example, allow users to adjust very specifically for higher part durability or easier post-processing.
So what is the voxeljet HSS material and what is so special about it?
The voxeljet HSS material network is a close technical alliance between voxeljet and renowned material process and production partners for the development and optimization of innovative materials and processes that have been tested for 3D printing on voxeljet HSS systems. At the same time, it offers voxeljet customers a smart way to enter the 3D printing polymer market without the risk of having their own production capacities.
So how do I have to imagine this? With what issues do I contact the HSS network about?
In principle, anyone can contact voxeljet with their concerns and questions about HSS. We will help in any case, and then the right experts from the HSS network who can offer the right solution for the specific question or task. To answer the question, the expertise in the network is very deep and broad. On the other hand, 3D polymer parts can be easily sourced from selected production partners in the voxeljet HSS network. This is interesting if you want to expand your production capacities at short notice, or simply want to have parts produced as a service in 3D polymer printing without having to make your own investment. This approach is also interesting for newcomers to 3D printing, for example, to explore whether this technology pays off and can be used in your own production.
And on the other side?
voxeljet HSS network partners who can help if you want to realize a specific solution. A solution that has to be tailored exactly to customer-specific requirements. For example, if a special part properties are to be achieved using specific materials, or polymers that are simply not yet certified in the HSS process. In this case, the voxeljet HSS network is the right partner with the highest level of HSS expertise to develop and test materials and tailor the HSS process precisely to the application.
So, what materials have been qualified so far and what is possible in general?
It's an interesting question. Well, more than 30 different materials have already been successfully tested for the HSS process, and more will follow. This underlines the versatility and material tolerance of the HSS process. The materials already include spherical grain powders in a range of particle sizes from 30 microns to a whopping 1.3 millimeters. This flexibility in terms of particle size and material composition enables a wide range of applications, allowing production to customize material formulations for specific performance requirements. The high variability and customization options of the high-speed sintering process thus enable a sustainable improvement in the mechanical properties of 3D printed polymer parts and pave the way for completely new fields of application in additive manufacturing. So, yeah.
All right, I have no further questions. So, Christoph, thank you very much for walking us through the VX1000 HSS in such detail. And for everybody out there, if you have more questions about the HSS or the VX1000 HSS in particular, please get in touch with us anytime. We're always happy to help.